Okay, so for this lesson, I will just go straight to kNN, and it is the part about the scratch. So I think the idea of kNN is very straightforward. You ask the opinion of your neighbors. If most of your neighbors say yes, then you say yes. It's like a typical. Okay, at least for me, I do this all the time. Okay, so that's the idea of kNN. You follow the majority rule of your neighbors. So it turns out that in practice, finding the nearest neighbors can be time-consuming. Okay, so suppose that, say, we have 10,000 images, which is just a moderate size of data. Okay, and if you want to calculate the pairwise distances among the 10,000 points, then it is a big matrix. And not just that, between every two images, you have to calculate the distances. We are using a very low dimension, low resolution image, so the dimension is much smaller. It is only 8 by 8. But you know, most of the picture taken by your phone or by your camera, it is usually at least like a 3,000 by 4,000, that kind of scale. So it really takes some time to just calculate the distances. So to do that, it could be time consuming, and we haven't talked about how to pick the minimum yet. You still have to do the sorting for each row. So doing that could be time consuming. So it turns out that there are some algorithms to get it more efficient to find the nearest neighbors. And unfortunately, I'm not going to tell the details about that, and I don't know how it works. So I'm just going to tell you that for sklearn, these functions are implemented in the model called nearest neighbors. So let me copy it here. So from sklearn.neighbors, this is the folder also include the kNN module. You can import. I somehow feel like I should just type it, right? Okay, so let me type it and then copy it to here, because my writing is not so well. Okay, so you can do from sklearn.neighbors import nearest neighbors. Okay, so this is different from what we did before. What we did before is k-nearest neighbor classifier or regressor, right? So these are two different things, but it is in the same folder. Now you can say neighbors is equal to nearest neighbors, and depends on how many neighbors you want. You can say I want 5 nearest neighbors. Then this is a model to help you to find the nearest neighbors for every point. Now you can say model.fit. Again, this is sort of loading the data of X. Oh, it's not called a model. It's the MBRs. Oops. Let me check it. Sorry. Well, I guess I don't need to set up anything. Okay, so let's say we want to set the 5 neighbors, and then we can do MBRS at a fit. Then you successfully build the model inside its memory. Now you can ask what is the nearest neighbors. For example, you can use xtest. Okay, and you can use the k-neighbors and then try to ask what is the nearest neighbors for this new data sets. And you will generate something outside, and it depends on the output format, right? And so let me copy it to the other side and do some explanation. I'm not sure if you noticed that whenever I'm not using this platform, when I switch to a different screen, that part is not recorded. So if you are watching this video, then the past 3 or 4 minutes, you only see something like this. Well, you don't see anything. You only see a blank things. Well, you only see something like this, and I'm keep talking for 3 minutes. You did not see me typing. So anyhow, this is the code to find the nearest neighbors, and let me explain what does that mean. Okay, notice that you are doing the fit, right? So this part helps you to load the data. And this is the new data. Okay, so new one. And you will see that it gives you 2 things. And I just want to say that, okay, based on its design, the first place of the numbers, these are the distances. Okay, so you will see that these numbers are about the same. There are the 5 minimum distances among all the 1700s of numbers. And these are the corresponding indices. So this is the indices. Okay, so this is a better way to find the nearest neighbor of 1 point or several points. You can input several points together and you can get the result. And let me show you one more thing. If you do MBRS, you can set the algorithm. And there are a few different choices. By default, it is auto. Yeah, let me also copy it to the other side. By default, it is auto, but you can also search for other options. Other algorithms. You can say auto, and I think you can do brute. Brute means brute force, and usually you wouldn't want to do this. And there are something called a k-tree. I will check the spelling later. And the other is called bow trees. Okay, so here are the options: bow tree and KD tree. So using the different algorithm basically give you the same result, but depends on the scale or your data type or data specialty, then it will give you a different performance. By that I mean the speed can be different. So usually it is enough to set it up as auto, because auto will automatically give you the appropriate algorithm. You will decide whether to use this structure or use that structure. And these 2 things are like a special algorithm to help you to find the nearest neighbors. Okay, so the main purpose for here, just try to let you know that finding the nearest neighbors can be time consuming, and so there are some built-in functions help you to do this. And they are using something like a KD trees. This is the name of the algorithm. KD trees or bow trees try to figure out what are the nearest neighbors.